Okay, I think the recording. Good. This a little bit together. Hey guys,
Morning, Mike.
how are you doing?
No complaints? Yourself?
Yeah, good. Good. You can hear me then?
Oh, yeah.
Ah, cool.
That
Good.
chopper video was amazing this morning.
Yeah, I've had a very, very productive day today. So, yeah, I managed to get sound in chop. I need some bigger speakers actually for him. And the sounds that are out there aren't too clean, so I might have to look at trying to grab some better ones, really. But yeah, we've got sounds, we've got lights, we've got a working Padawan 360 in there. I just got to do all the servos now, which is a more complex thing.
Oh, details.
How's everyone else? We got lots of thumbs up.
Hey, everybody.
Hey, right, I've managed to remember to record this one. I didn't record the last one. It's schoolboy error. So we will have this for posterity.
Yay!
We'll give it.
Looking back for reference. Excellent.
Yeah, well, I said that I've got a load of quite complex stuff to do on Chopper to get all of the arms in the head moving and the periscopes and all that sort of stuff. And the Maestro seems like a ideal bit of technology to do it. So I thought if we just do a nice, easy sort of 6-part exploration of the Maestro, how it kind of links up to the Arduinos, and just kind of explore it together. So I think it'll then hopefully translate to things like the R2s and anything else you're really building, because once you can load a sequence on the Maestro, trigger it through an Arduino, you can pretty much run it from anything then. And the BD1s, of course, Alex. Yeah, so I think that's if I'd have known about the Maestro when we were doing the BD1s, it would have made the automation mode a whole bunch kind of easier. Right. We've got about 20 or so on. I think we'll get started if everybody's up for that. Cool.
Yeah, great.
Excellent. So yeah, just double check I'm recording. I am recording. Have to check 2 or 3 times. Yeah. So the plan really is, as I said, just on the entry, which is the kind of these little boards here, which is the Pololu Maestro 16-channel servo controller. What I want to do is just do a step-by-step exploration with a group of people to see how they work, play around with them a little bit, learn a little bit, and then with the end game of intending to install it in Chopper and running it off the Padawan 360. So what we'll cover off pretty much today's session, we're going to cover the Maestro. If you join the last Maestro session, we'll probably go over a lot of similar sort of ground, but hey, we can always listen to these things twice. The next one then we'll have a look at the Padawan 360 and how that kind of runs, and then we'll get into a little bit more in depth on linking the Maestro to the Arduino and triggering some of the animations off it, and then sort of building up really to then looking at how we can capture some of the key controls from the Padawan 360 and get it to trigger some of the animations. And if we can do this, and if you can get a handle on it, what it means is that anything conceivable that you can imagine animation-wise and automation-wise, you can actually run off one of these little boards. And they're really quite clever. You can also run LEDs and you can use these as inputs, so that they're almost like a little Arduino themselves. But anyway, we'll jump into it. You got any thoughts, questions, observations, or sarcasm throughout? Just throw it in. Don't worry about it too much. So let me just change the view. Okay. So yeah, so I've got a little test rig to play with, which is this little thing here. It's the head off there's a new one of the new micros. It's not that micro actually, but I'll just kind of show you while you're there. It's a six-wheeler, six-wheel drive, almost little rover. So when it all goes together, it kind of a little bit, kind of looks a little bit like that, if you can see that. But on the top, there's this little dome, which I thought would be really quite handy to play with on. Maestro. Cool. So we'll get started. So we'll get started. So the only problem with these boards that small is sometimes you can actually lose them. So this is the Maestro, the Pololu Maestro, and this is a 12-channel Maestro. So I'll cover off a little bit around what these boards are. They're made by Pololu, the kind of electronics and motor manufacturer. And what they do is they allow you to simultaneously control the number of servos. But you can, as I said, you can control LEDs and all sorts of things with them, but we'll stick with servos for the sake of today. But you can also load scripts on here, which will do animations where you're controlling multiple servos at once. But the other very, very useful thing that it actually does is it controls the speed of the servos. So, and what I'll do is just so we're all kind of starting at the same position, I'll just talk through very simply what the servo is and how it's actually controlled. So I've got a little servo here. I don't, if you've not got a servo tester, I'd highly recommend getting one of these. They're fairly cheap, get them off Amazon. Oops, have to keep on. And I've got just a little battery which I'm just going to plug into here to power it up. And this is a handy one actually because it's a digital servo, so it'll tell you exactly what position you're in. Servo controller. I'll just plug the servo in. So effectively, there's a servo, and you can see now as I'm spinning the dial, it's moving the servo. Now, the way that servos work is they have a little pulse that goes to them, and the pulse width can be anywhere between 1,000 and 2,000. It can go as low as 800 to 2,200, and it can actually continue. And depending on the pulse it sends to servo, it actually dictates what position it's in. Now, moving servos around and animating them, particularly for what we do, one of the challenges we've got with servos is you're limited by the speed of the servo. So they do tend to be, they move to a single position and they stop. So there's no kind of organic speed up or slow down. There's no way of controlling the speed of the servo. It just goes to that position as fast as it physically can do. As you send these signals. Now the Arduinos are great because you can send any of these numbers through the software to the servo and you can move it to a single position. The challenge you've got is when you want to do animations or you want to do things a little bit slower than the servo is capable of, it becomes very, very, very complex. Hence why we've got one of these. The other drawback I think with using these direct from the Arduino is each servo effectively takes one pin on the board. So you do have a fairly limited number of servos that you can start to connect to. So what I'll do is I'll now take the Maestro and I'm just going to connect it. It's very similar to how you would connect an Arduino. So it's got a USB connection. Cable is one of those, which is I think I can't remember, a Type C or a micro. I can't remember. A small USB. Plug it in, and once you plug it in, you get a little green light, and that means that you're actually communicating when you're connected. Now I'm just trying to talk out on the pin. So within the servo, within the Maestro, you've got a bunch of pins down here. These are obviously the 12 channels. The very top one, which is the 13th one, is the power. With most servo controllers, you don't run the power off the same source as you actually run the logic. You have a separate power supply, and the reason for that is that when you've got multiple servos, and particularly as you get some of the bigger servos, it can draw quite a lot of current, so it can cause problems with if you try to use a power supply off a micro or off USB connection. So that top piece there is where you would apply the power, and then each of these are channels, and then just on this side there's a bunch of pins, which is your logic connection for if you want to connect it to an Arduino or other type of device. So what I will do is, for the sake of power, I've got a small battery here. I've also got a big LiPo which I'm going to use. I'm going to use a LiPo in something called a UBEC. What a UBEC is it takes the power off a LiPo and it just converts it to 5 volts. These are sort of things that you could use in your own droids to step down from 12 or from 20 volts into 5. I'll just plug it in, just to give me power supply. Right? So I've now got a 5 volt supply. So as well as the logic being powered, which is being powered by the PC, I've also got an additional 5 volt supply, which is going to be for that power for the servo. If I don't power the servos won't move because they won't be powered by the USB, if that makes sense. So I'm just going to plug that in, make sure I get the polarity right. For those of you who've not done a lot with servos, the middle wire on any servo, which I don't know if you can see there, the middle wire is always live. And the reason for that is if you do get the servos, because the 3-pin connectors that can go either way, if you do get the servos cables in wrong or back to front, you won't actually damage the board and you won't damage the servo. As long as the live wire is in the middle pin, you're okay. And that applies to these, but it also applies to things like servo testers and radio control receivers. Okay, so what we've got connected now is we've got the USB connection, and I've got a separate power supply to power the servo. I'm going to plug the servo in. Plug that one in. I'll plug it into channel 0, which is the first channel. Okay. I'll pop it on there. Now, what the let's see if I can share my screen. Yeah. Okay. I don't know if can you see? You should be able to see both now. I think you can see the servo in a small screen, and you can see the screen that I've just shared. Is that right?
Yeah. Yep. You can see that.
Okay. So what I've just shared is this is the software that comes with the Maestro, the Pololu Maestro. It's called the Pololu Maestro Control Center, and this is kind of your starting point for anything that you want to do around with servos. So the first thing is connect it to USB, and then if you just do a drop down there, it'll have the serial number of the device, and it'll pick up with a firmware version. Once you've done that, again, I don't know if you can see the green light is blinking quickly now on the Maestro, because now what it's doing is it's sending data back and forth from the PC to the Maestro. And this allows me now to completely control all the servos that that one's connected to. So at the moment, I've only got one servo connected, which is into that first channel. And I'll take you through what all of these things mean in the first in a little bit more detail shortly. But if I enable this servo here, and then it gives me a slider, and if I move that slider back and forth, you can see the servo moving. Yeah, you can see that. Now, one of the things that I said was quite difficult around with servos is trying to control the speed of them. But and this is really where the Maestro comes into its own, because what you can actually do is you can set the speed to any speed you want. I think the top speed, I think, is 1024, but I'm not 100% on that. I'm just going to set that to 50. And if you watch the bar on the software now, as I move it across, the little blue dot lags. And what the little blue dot is it's actually, that's where your servo is. So what the software is actually doing and what the board's actually doing is it's creating a series of pulses that step the servo through that position. So as you can see now, you see on the video, it's moving a lot slower. And you can drop that right down. If you drop it down to 10, for example, you can see it's just absolutely barely moving as that little blue dot's moving across. So that in itself is very, very, very useful, because trying to control the speed of servos when you want arms to come out or panels to open is a nightmare. Now, the other thing then that you can actually do, if we put that speed back up to say 120, you can play around with these. So 120 is quite quick, if you can kind of see that moving. Is we can add acceleration. If I put an acceleration of 12, and I'm picking numbers here, you can play around with these. If you watch the blue dot, what it actually does is it starts off slow and speeds up. So what you actually get is a lot more of an organic movement then in the servo than what you would do when you just end up sort of moving it quickly back and forth. Does that make sense? Stunned silence.
Yes.
Cool. And again, you can play around with both the speed and the acceleration settings to get it where you actually want to. So this, in the software, in the Maestro software, what you've got on the first page is you've got status, and the status is where you can see all of your servos live and you can actually control them. And you can tweak these numbers, so you can move them around. Now, if you look at, if we just step through this, what you've got at each of your 12 servo channels, you've got your target, and if you remember we said before, it works in these kind of numbers between 1,000 and 2,000. So that, if I put it into 1,500, which is typically the center of a servo, it'll be right in the middle. If I move back down to there, it goes to 800, and it goes to 2,200. Then you've got the speed and you've got the acceleration. So that allows you to then sort of shift that around. So what you've got on the target is where it wants to get to, and the position is where it currently is at. So if you start turning the speed right down, you'll see there'll be a lag between those two numbers. And literally, you can connect 12 servos onto that single tiny board, and you can control all of those through this particular bit of software. Now, there's some other tabs on here. So there's an errors tab, which this just tells you if there's any errors coming back, which I won't go through in any great detail. And then you've got this tab called channel settings. Now, what your status is a live view of your servos. What the channel settings is, it's the default settings for the servo. So I've set my speed to 240 and acceleration to 12. But if we look onto channel settings, my speed is 72 and my acceleration is 20, which means that if I reset, if I power down and power it up, or if I do anything that kind of breaks this session, these will be the defaults. So if I wanted to default that one to 240 and to 12, I'd go into here, I'd put 240, I'd put 12 into there, and it means then every time that board is powered, it will apply them settings. When I hit apply settings, which is the button at the bottom, what it's actually doing is it's recording those settings then into the board itself. So the board itself has got a memory, which means that it can understand the default speed and acceleration settings that you want for each of those individual channels. So I've set the default to 12 and 240. If I enable that servo now, it's now at that 240 and 12. It's working as it was before. So your channel settings will always override your status. Your status is a live view. You can tweak, you can play around. So I put it at 1024 with acceleration 60, so we'll get some really quick, which is nearly sort of full speed. But if I go back into channel settings and I make a slight tweak and it's apply, it resets everything back to what it was previously. So status is your live view. Channel settings is the view, is what's stored in this little tiny board. Then we've got some serial settings, which again you don't really need to touch because that's just how it's connected to the PC. And then you've got these things called sequences, which we'll cover now. I think just to have a look at these. So, as I said, if we think about what advantages this gives us, the first thing it gives us is really nice speed control, and also very natural speed control because you're not going at the full speed of the servo and pulling to a dead stop. It's gradually slowing and gradually speeding up because you've got acceleration and deceleration that's in there. Now, what you can do then is you can start to build up sequences. So if you wanted to have a door that opens, an arm that comes out, if you wanted the panels on the top of R2 to open sequentially, you can start to build sequences up through this. So I'll show you very simply with that single servo that we've got. So if we start at one position, which is there, and then what we want to do is move through smoothly to a second position, and then we want to move back again, and we want to make that as a sequence. What we're doing is we're creating frames. So frames, very similar to how people make animation, frames are a step in time that it's going to move to. So if I click save frame 0 at the bottom, I'll then move my servos to the next position I want to, click on save frame 1 and move it back, and click on save frame 2, move it forward, and you get the idea. Save frame 4. So if I then move on to sequence, what I've actually done is I've created 4 of these frames. So if I hit play sequence, what happens is the servo starts to move. Now, if you look at it, I've actually got 4 species there, but four places it's stopping, but it's not actually moving to 4 places. And so I'm going to go back to, I'm going to click on play in loop. So it's just going to keep playing these 4 animations in a loop. And I'm going to click on status, and I'm going to show you what's happening. So what it's doing, what it's done at the moment is it will always separate an animation by 500 milliseconds by half a second. And so every half a second, it's now moving the target somewhere else. That makes sense? But what's actually happening on the servo is the servo's speed and its acceleration means it can't get there before the goalposts change again. So what it's doing is it's constantly chasing wherever that target is, but not able to get there. So once you've kind of done your first attempt at a sequence, what you've then got to do is just go in and start to edit these durations. I'll put it to 1200, or edit the speed so that you start to get the animation that you want to. And what it's doing in the background is it's kind of building up a bit of programming or code similar to Arduino that's going to allow you to then load that onto the Maestro. So I'm just going to put all of these to 1.2 seconds. There we go. Right. So now all I've done is extended from half a second to just over a second. I'm going to play those in sequence and see what that does now. If you look at the servo now, it's doing a bit more like what we expected it to. So if we look on the status, what I've got is I've got the target moving every 1.2 seconds, and I've got enough time for the little position of the servo to catch up with that. I'll just pause for there. Does that make sense to everybody up to now? Cool.
Yeah. Hey, Michael.
Any
Hey,
questions?
can you hear me? Hey, can you hear me?
Yeah, I can hear you. Yeah.
So can you go back to your sequence tab just a second? So
Yeah.
so from what I'm looking at, you can have multiple frames and you can have multiple sequences and multiple frames within a sequence. Is that right?
That's right. Yeah.
Okay. All right.
Yeah. Yeah. So, and we'll jump onto that a little bit more. But what you've actually got at the moment, we've just got one sequence with the multiple frames that are in it. But if you've got something that you want 3 different types or 4 different types of animation using the same set of servos, you can create each one of those as a separate sequence. So they'll do different things depending on the sequence that you call. And where we're going with this is ultimately you're going to load all of this not on the computer as it's running now, but what you'll do is you'll upload it to some memory that sits inside the actual Maestro itself, which means that all you've got to do then when you trigger it from the Arduino is say run sequence 1 and it'll do that animation, or run sequence 2 and it'll do that animation. Yeah.
Thank you.
Okay. So I'll go back to status. So what I'll do is I'll just unplug this servo. I'm just going to plug this this eye in because it's probably a little bit easier to see what's going on with this one. Plug this one on. Let's make sure I've got the, there we go. Right. So you can kind of see the eye moving back and forth. Now what I've got on the on this model is there's 2 servos. So there's a servo 1 and servo 2. So servo 1 moves it like that, and servo 2 moves that way. Okay. So again, I've got some MG92Bs which are quite aggressive servos that sit in here. So at full speed, it kind of goes a bit like that. So you can kind of see it's quite keen when you do that. So what I'm going to do is I'll just default to speed of 60, acceleration we'll do 18, acceleration 18. I'll do them because we're going to pair these 2 together. And then when I hit apply settings, that's now saved that into the Maestro. So that's the default, what we're actually doing. So I'll enable those 2 servos, and that's your kind of speed that's going through there at the moment. Okay, so what we'll do is I'll just show you how you kind of build up a little bit more of a sequence then. So if I just get rid of what we've got in there, so what I'm going to do is I'm going to start with the eye about front and center. I'll hit save frame 0. And then what I'm going to do is I'm going to have the eye look that way, save frame 1. I'll have the eye look that way, save frame 2. And then what I'll do is I'm going to flip back and I'm just going to lift it up a little bit as frame 3. And then I'll turn it a little bit that way and get it to look right up. And then I'll turn it that way and I'll get it to look right down. And then I'll move it, and you can literally, obviously you're moving it to different positions. So what you're doing is you're building a bit of an animation sequence. The beauty of the eye is you've not got a lot of timing, so you've not got doors that open and arms that could crash into the door. You can just play around with that. So what I've done here is I've very quickly built a 10-frame sequence. So if I play that sequence now, you can now see that eye is now just moving away in whatever direction it wants to. If I go to the status, what you can see here is it's moving pretty quick, and the blue dots are not quite catching up where they would want to be. I move back to sequence. What I'm going to do is I'm just going to slow these down a little bit, and I'll take these to say 700 a piece. So we've got a bit more time for it to move around. That makes sense. And all this really is part of sequence 0. So 100. And what I've been doing with Chopper on this is taking things like the arms that are in the head with the door that opens. So the door's open on the head, the arm comes out, the arm flexes, and then the door closes. And you can literally do it step by step and just alter the timings till you get the animation that you want playing through this kind of interface. So I'll play that sequence now. So now it's giving it a bit more time, so it's actually getting to where it needs to be. What you're actually getting now is you're getting a fairly sort of organic looking movement from the eye as it sort of moves around a little bit. So these are really quite useful for building up those sequences. So let me just stop that sequence there. There we go. Okay. So now what I've done is I'm happy with that. So that's a sequence. That's an animation sequence that I'm quite happy and I want to keep. So what I can do is then I can start to shift this into what's called a script. So in the up until now, the sequence is stored in the PC. It's stored in a bit like reading an Arduino sketch. The script is where we start to then push it into the actual Maestro. So if I say sequence 0, and what I'm going to do now is I'm going to copy the sequence to script. What that says now is raise your current script you want to proceed, because what you're actually doing is you're copying this a bit like when you would load a script on a sketch, sorry, on an Arduino. This is copying actually into, when you hit apply settings, you've now copied that script actually into that Maestro. So if I then run that script on startup, for example, and apply settings, every time the Maestro starts, it will run through that script. And if you remember on the script, on the sequence that we put, we also told it to play the loop. So rather than it now, as you can see, that sequence isn't running. This is actually the script. So this is running directly from the Maestro. I could just leave that if I wanted to, and what it would do is it would just keep running in a constant loop. If I just unplug the Maestro now, I unplug the power from it, and then I just fire it back in again just to sort of do a bit of a reboot. You can see straight upon power up that script is now running. If you look on the control center, what it's saying is that it's not connected. In other words, this isn't the PC that's running that now. That's running off the script that sits within that Maestro. So if I click on that, I'm now connected to it. And if I hit stop script, I can now stop that on the Maestro. Okay. So, any questions or thoughts so far?
Yeah, I have a quick one.
Yeah, go for it.
Can you also adjust deceleration, or is the acceleration, does it work in both ends of the movement?
Yes. So through this interface, the acceleration and deceleration is the same. So if you let's put it on 2, I think. So if you watch it, it's like it accelerates and decelerates as it gets closer.
Okay, so they will be the same. Okay, great.
Well, they will be the same. Now, what you've then got is what it's actually done is it's took all of the things that you've done through this interface, and it's created this script. Now, similar to Arduino's, what you've got in the background is a load of other commands that you can apply to this script, because there's a lot of limitations by just doing this. Is really your starter for 10, so this gets you up and running and working. But what you can then do is, as you start to get more familiar, you can go into the script. So within the script, it means that you can, on the fly, alter both the speed and the acceleration. So you can tweak all the settings as you go through it. And what I'm not sure about is whether you've got independent acceleration and deceleration values. So I've not read through all of the commands yet for Maestros, but I will do by the time we get through this 6 weeks or 6 session period, hopefully. But there'll be there's a lot of powerful commands that you can then add to the script to customize it as it goes through.
Yeah, makes sense. So this user interface is kind of simple, but you can, tweak till your eyes are blue. In the
Yes.
scripts. Yep.
Yeah. So one of the I guess limitations of doing it this way is, for example, one servo can only ever have one speed and one acceleration. So you can't change the speed and acceleration midway through a sequence. Whereas what you can do is go into the script, find out when it's completed frame 2, for example, and then you can insert a command that then changes the speed and the acceleration. So the command language does give you quite a bit more powerful controls that sit over the top of it.
So if you change this servo speed, for instance, and you make a new frame, the speed is not reflected into the sequence?
That's right. Yeah. The default speed and acceleration comes from here, so it doesn't change on the fly even if you add another frame. So the frames themselves won't store the actual speed of the servo, but what you can do.
So the frames will get it from the channel settings, not from the status screen where you change things.
That's right. Yeah. Yeah.
Okay.
But and again, this is where you can start to insert the commands to alter that speed midway. So you can do everything through the script. It's just this was really just I guess the first sketch, if you like, of what the animation is that you want, and then you can go in and start to fine tune it through the script. Me personally, I've not got to the stage yet where I've gone into the scripts and started to fine tune it, because actually this works a hell of a lot better than it did do on when I was just running servos through Arduino. So it's pretty powerful on its own, but it does give you the opportunities to start to go in there and do a lot more intelligent things with it.
Well, it seems a lot less scary this way too. For those of us who aren't coders.
Yeah.
Yeah, exactly. You can just pull some levers and be happy with it and save it, and off you go. It's brilliant.
That's it. And what you saw there, which I put copy sequence to script, and what that's got is it's got one sequence that I've just copied across to Maestro. Now what you can do then is you can click on new sequence, new sequence, new sequence, and what you end up doing is you build in a number of sequences here, and you can obviously rename these to head movement, arm movement, all of these sort of things that you want to that are more meaningful to you. But when you click copy all sequences to script, what it does do is, rather than copy one sequence that it'll just keep running over, it copies a load into the memory, and then from the software that you've got within the library that comes with the Arduino, you can call off individual sequences. So you can just trigger it and say, run this one, run this one, run this one. If that makes sense.
If you have multiple sequences installed, does it just run sequence 1 when it reboots?
If you're not calling it from an Arduino, it actually errors. So there you go. So if you try to apply, let's just clear all these sequences out anyway. There's the right sequences. There we go. Yeah. So with you, let me just stop scripts. So when you've got multiple sequences loaded, it doesn't auto run the sequence, because what it's doing is it's waiting for an Arduino or something to tell it which sequence to play.
Okay.
So if you're doing a single one, you just load one and you can have it auto run. And again, I'm thinking of doing this. Well, I'll have to do this for the chopper arms in the head. But what you can have is a cleanup sequence at the beginning, which opens the doors, waits a second, folds the arm up, and pulls everything back to its default position. and you can have that running on startup, and then everything's neat and ready so that when you start to run the animations, you can do. So that's what I want to do a little bit with Chopper. Has anybody got one of these boards out of interest?
Michael, I have a question.
Yeah, go for it.
So really what this allows you to do is from the Arduino, say, call a sequence from the Maestro that says, open the door, and then call another sequence that says, okay, after that, then send up the periscope or send something else. Really make your code clean on the Arduino because you got all the goofy stuff happening on the Maestro. Is that right? Or am I thinking that right?
That's correct. Yeah, and this is one of the big advantages of it. We were just covering before, you know, where one of the things that's very difficult to do on an Arduino is manage the speed of movement, because to slow a servo down, what you've got to do is you've got to step it to every individual position, which means that the Arduino is constantly just going through a loop saying, right, now move to 1, now move to 2, now move to 3. And all of that takes processor power up. And then it's got to manage the timings for the door and all that sort of stuff. Whereas what you've got with the Maestro is you literally send one command from the Arduino that says, open the door. The command might be run door animation. And then what it'll do is it'll open the door, it'll pull the arm out, it'll wave at you, it'll put the arm back in, and it'll shut the door after itself. And you can do that off one call from the Arduino. So it takes a lot of the processing power away from the Arduino.
Michael, I do have 4 Maestros running in my R2 doing various sequences. All of mine, though, are triggered from switches on a 10-channel RC as opposed to an Arduino.
Okay. And how'd you find that?
I got an RC switch that actually just sets the value high when the servo is active, and use that as an input trigger from 0 to 255, so that it just simply tells it that it's now high rather than low. And in my sequences, the script that starts running is actually sampling that input line, looking for the change for that switch. And when the switch goes high or low, depending upon how I've triggered it, it keys the sequence, runs whatever it needs to do. And then in that same sequence, at the bottom of the sequence, I program a loop in order to watch for the switch to go back to its original position, which then reverts, closes the door, puts away the interface or the gripper or whatever the case may be, closes the door as the case may be. And that seems to have been working quite well for me right now.
I just bought a Maestro to get to start with this. When you're hooking up your servos, which side does it matter which way you hook it up? Because
yeah, you want your signal to be most inboard.
So the yellow one goes towards the lights.
The inside of the board, but there's
okay.
You know, I don't want to take Michael's show either, but there's a great PDF for the Maestro that takes you through all 4 versions of the board and explains it. So go get that, and it has pictures. It's wonderful.
Okay, because I just finished up soldering it and hooking it up to the computer and downloading the software, and so I was going to start to play around with it while you were talking. So cool.
Yeah. So
I'll put the link, Michael, while you're doing this. I'll put the link to the Maestro guide.
Excellent. That'd be easier than me.
Fantastic.
Perfect.
Yeah, brilliant.
Perfect. Thank you.
Yeah,
Michael,
sorry, go on.
Oh, I had a question. Since I'm building BD1 now, and I'm doing if I do with the controller, is there a way to have the Maestro in there, but also bypass it at times so that all the pots and everything will control it the way the Adafruit controller does? I think, can you send it serial commands from the Arduino for positions?
Yeah, it's It's an interesting question. I certainly know you can do either or. What I'm not sure is that you should be able to switch between the two. So I'd have to have a look at the library. I've not had a look at the library in depth, the Maestro, but from what you've got is you've got sequences that you can call from the Arduino, but then you should also have positions that you can call, which is the live data. So I would imagine that you should be able to do both. But what you'd be doing is replacing the Adafruit servo controller with the Maestro, and then running the serial communication in the same way as you would do on the I2 squared cabling. And then I think, and again, I'd just have to have a quick flick through the library for the Maestro, but what I'd imagine is you can either send it definite positions, as in where you want the servo to go, which would be straight off the pots, or what you can do is if you press a button, then it can just fire through a sequence.
Mm-hmm. Okay. Yeah, that's what I was hoping to be able to do.
Yeah, if you have a look at the if you download the Pololu Maestro library and then go to Sketchbook examples Pololu Maestro, can't get my words out, and then have a look at Smooth Servo Control. That will show you how you set a target. So you can actually in the Arduino code set a specific target for which for servo 0, 1, 2, or whichever one it is, to achieve a particular location. That might be the answer to your question. And at the same time, you can also still run scripts. It's just Maestro dot then set target, for example, or Maestro dot run script, or whatever it is.
Perfect.
That will be amazing on the BD1. That will be amazing. In fact, I'm going to rip mine to pieces and put the Maestro in now, I think, to be honest.
One thing to reiterate.
It'll be the BD 1.2.
One thing to absolutely reiterate, and I apologies for being a bit late to the meeting today, but the one thing I would heartily encourage everyone to do is not mess around too much if you're using the Padawan 360 sketch. Don't start messing around too much in the Padawan 360 sketch unless it is specifically to tell the Maestro to run a script. Because otherwise, if you say, well, actually move the servo here, and then after 500 milliseconds, move it there, you're introducing a delay in that script. And we absolutely want to avoid introducing new delays into that script. Let the Pololu look after all of those timings, if you like, and don't. All you want to be doing from the sketch is triggering an action.
Yeah.
And then immediately return back to the loop.
We're just going through the Maestro today, Steve. So I'm not. I know you missed the first bit, but
no, it's just it sounds like people are keen to start getting into some of this stuff, especially when they're saying how do you set a specific location? Well, through an Arduino sketch. So I just wanted to to just not warn people off it, but just tread very, very carefully, but have a mess around with it, have fun.
Well, yeah, the first iteration, he's fixed it now, Dan, because on the chopper with the Padawan, he now uses the millisecond. There's two different ways of doing timings. You can actually just put a delay where it'll wait, or you can use a cleverer way called milliseconds. And the first one was a delay when he had animation on the dome, and it used to scare me because you'd be driving your R2, and if you had auto dome on where that dome would just move left and right, every time it moved, you'd have no control for about half a second. Whatever direction it was going in or wherever it was doing it, just continue. And that's what Steve's saying, really, is that if you start to introduce delays into the script that stops it reading the controls, it can get quite hairy when you've got a large droid that's driving towards a large group of children or whatever you want to drive it towards.
Okay, Michael.
Yeah.
I have plugged in 4 servos. I've connected it. It's recognized by the Pololu Center. But when I adjust the sliders, it isn't moving the servos. Do I have to do something to enable that?
Power the board.
You have to power the board. So,
got it. Okay.
So and this is where, I don't know if you can.
The U-big, okay.
Yeah, I'll just let me just stop sharing the screen a little bit, and we'll hopefully you can see the main screen. So on the board, what you've got is these are all the servos, and right at the very end where you've got this little blue pin, that's where your power is. So you have to apply 5 volt to the middle one and ground to the outer one to actually power your servos.
Okay.
Separately from the USB thing. The way I remember it is if you look at that middle, you look at the middle open pins, one of those solder blocks is square. The square one is the ground. Your 5 volts always goes to the middle. Your square one's your ground, and your inner one is then the signal.
The first 2 pins in from the USB connector right there, Michael, you can provide 5 volts to power everything. And then with that blue jumper, if you turn it sideways so that it jumps from the pin it's on now to the one next to it, then providing the main 5 volt over near the USB to the first 2 pins, and then jumpering that the way you're doing it, that'll put 1 5 volt supply that will power the entire board, everything on it, the servos, the whole 9 yards.
So like that.
Yep. And the only thing you need to do there, the only thing you need to do is just over near the USB connector. If you put the board in there again, the first 2 pins coming up from there on the edge there are the 5 volt in.
Yeah.
Yes, exactly. So you put the 5 volt in the ground on those first 2 pins, obviously in the proper order, and then that will actually power the entire board. And by putting that jumper in, you now power your servos and everything else all at the same time.
The spec actually says 5 to 16 volts, so it must have an onboard regulator too.
Yeah. Yeah. So
I think the 12,
the amount of amps
the 24.
What's the amount of amps that can be pulled through there?
3, I believe, is the grand total.
But all servos.
That's something to be careful with if you're doing some larger servos, because some of those things can pull quite a bit. I run separate power to all of mine, and then run just the signals through the board.
So
I also put the link to that RC switch that I mentioned in the chat if anybody's interested in that. I know that doesn't apply to using an Arduino, nor does it apply to doing the things with this, but it works quite nicely.
So if I've got a 7.4 volt battery here, can I plug that into the part you were talking about?
Yes, to power the board, but you have to be careful not to put the jumper to then use that high of a voltage on some of the servos. So so remember, if you're going to use the jumper so that you have one power supply, I want to make sure that it is within the proper range for the servos requirements as well as the board. So even though the board, yes, can take in, as it says, up to 16 volts,
more,
it
you don't want to burn out.
You know,
you don't want to burn out your servos by using 7 instead of 5, right?
Rumor has it that burning things out is a thing you don't want to do. You get movies made about it.
I've already
you're just guessing.
Burn out a few servos myself, so I'm absolutely.
Where's the fun in that, Rick?
Absolutely right, my friend. Absolutely right.
That was brilliant.
Sudden Sam is sudden.
Right, I'm just.
But get caught for stalking him.
Make a change for someone to be stalking Sam and not the other way around.
Oh, that's debatable at the moment, I think.
Well, I said, I think in one of the responses that was one of the few bright moments in 2020.
Brilliant. Right, so there we go. How are we doing? Have you plugged it in, or are you waiting till later to do that?
Well, I had managed to drop my little blue jumper thingy, but I just found it, so I'm going to be plugging that in, and I found my 5-volt instead of the 7-volt, so there won't be a problem there. So
Yeah, Michael, I think this is gonna. I'm gonna be doing this. This makes a lot of sense, particularly with Robbie's arms.
Oh yeah, yeah. I mean, it's ideal for anything like that. For anything that you're wanting to automate. I just while you were just doing, I was just loading a script that just moves the servo. And then now, if I unplug that, what we're saying, I think, is I can literally apply the power to there. See, I'm trying not to do a Rick here and go up in smoke.
The chat is being recorded, isn't it? So we can always make a meme out of it if needs be.
Exactly. That's why I'm making sure we do it right. Yeah. So what I've done there is I've connected voltage. I don't know if you can see there. I've connected voltage in. I've put the little blue jumper on the end, and I've got the servo connected, which is still running a continuous script. So that's not connected to the PC at all. And it's now that single power is now powering both the board and the servos. But as you said, I think you really only want to be doing that on 5 or 6 volts unless your servo can take 7.4 volts or whatever you want to pop on it. But they are a superb bit of kit. I think that the other thing that we covered off just briefly was which we'll probably touch on some of the later ones, is there is a lot more you can actually do with them. So you can use them to read inputs, which I think is what you were mentioning, wasn't it, about running them through an RC switch, so it can scan and it can read similar to what an Arduino does, and then you can apply logic. So they are pretty much like a small microcontroller, but specifically for servos.
Michael, have you run into any limitations of how many sequences you can put on this?
Not so far. There is, I think, is it 8K the memory on these?
8K, that is correct. Yep. 8K.
Yeah, it shows you on your script thing. It says 96 out of 8,192 bytes used on this particular one.
Yeah.
In the middle of the screen.
So you've got quite a few left.
Yeah.
Yeah.
And you can actually tie these together to use multiple ones, so then you can end up having one in one part of the droid, another in another part of the droid, and just run signal cables to them.
Yeah.
So that
and they're inexpensive enough. You could run multiples, so that if you've got input coming from different places, then let that input just deal with whatever it does on that one particular Maestro. And so I've got the grabber arms and the door on the data panel on one. I've got the gripper and the door and the and all of that on a different one, and the interface arm and the door on that on a different one. So I can actually do them all without loading down the supply, or I can do them separately, and it's very, very simple to program and inexpensive.
The other advantage of using multiple Maestros is that if you have got different servos that run at different voltages, for example, so you've got some heavy duty servos that rock the dome in Michael's case, on his chopper, and maybe he finds that with the additional weight of all the arms that the servo's doing that needs to be a more powerful one, where you could run that off a higher voltage different Maestro, for example, and just daisy chain them.
And unless you're willing to get into some complex coding, while it's tied up doing one particular sequence, it's not listening for any others.
No, there's in fact on the last chat there was somebody mentioned you can actually break there's a specific way of breaking tracks in the middle, so you can run the 2 banks of 6 at different voltages, Steve. So you can run.
Yes, that's right.
Yeah, so you can
If that's
you
enough
can
for you,
you
yeah.
can split across the 2 channels, can't you? So
Yeah, it's where those trackpads are in the middle. I believe you just put a screwdriver through those.
on
There was
the
a question
we'll
in the chat here, Michael, that somebody
Yep.
was talking about the startup positions for the servos. If you share the control again and show, if you haven't already, in the settings where you can actually tell it where to go right on startup. So go into the channel settings.
Yeah.
Just to answer that question, on startup.
Good point. Took that one in.
Yeah, well, there's on startup or error, and then the value after that tells it what to do on startup or error. So if you turn on startup or error, then when it first starts up, it's going to go to a particular place. So if you happen to have it that your servo direction, it wants it to be down, as you put there, 784 instead of 2208, to have the door closed when the thing starts up, you can actually put in your 784 there, and when it first fires up, it makes sure that servo is there before it gets everything running.
On that note, if it's running a sequence, can you interrupt that sequence?
Yes. Well, you can with a command. It has an
Manually,
interrupt
yes.
command. Yeah.
Through
Through your Arduino, you can interrupt it, or you can overwrite the one that's currently running, which you need to put a script in there. Whenever you activate a new script, check and see if the script is running before. That way, it won't activate a script over top of a script.
Yeah, but if you do call a second script over the top of the first script, the first script will stop, and then the second one will kick in.
Yeah, it just stops. And the bad thing about that, you may have an arm stuck out.
That's what I was getting at.
Could collide with another arm, which on Wally makes it difficult.
So what I did for mine, although before I started using the Maestro, I used a similar kind of idea, but using a second Arduino Nano to drive servos instead. And what I did with that is I had a pin assigned to a combo on my Padawan that resets the board. And obviously as it resets, it then goes to its startup position. And then obviously, so if the startup position is all the servo panels are closed, then you can very, very quickly trigger that doing it that way. So I imagine there's probably a similar way to do that with the Maestro.
Gotcha.
Yeah, that's something I'm going to look at, because again, with Chopper, the sequence between the arms moving and the doors closing in the head have got to be fairly tight. And particularly, what I'm thinking about is if you get a power outage or it gets stuck in a weird position, I want the doors to open fully, wait half a second, the arms to contract fully, wait half a second, pull the arms in, wait half a second, close the door. I want to go through a sequence that effectively puts it back to its default position safely, theoretically, off any position. So again, I think you can do that on the Maestro. Just have a little bit, play around with it. On the communications, and again, we're getting close to time now, but on the communications with the Maestro to the Arduino, which we'll cover off in a later date, they run via a serial connection. So I don't think, and it'd be interesting if anybody knows, I don't think you can daisy chain them as such, can you? I think you've got to run them on separate serial connections.
You can daisy chain them.
You can daisy chain. Okay.
Yeah, and on the larger ones, I think it's the 12 and above, it's easier to do those because it actually has a channel. It has a pin for that. On the other one, you have to actually I think it's in the instructions, it shows how to wire them for doing that.
So what you're doing is you're running one as a master and another one as a slave. So you've got a direct serial link to one of them that then controls the second one.
Yeah, and then in your mode selection, you've got servo input and output, and it could be an output that becomes an input on a different Maestro.
Okay, I'll take a look at that, because again, I'm in Chopper, as with R2 as well, you typically have a Maestro in the body, and you probably have one in the dome. So rather than running that through 2 serial connections, I can run it through one.
You can run it through one. You can fire them at the same time. So in one of the scripts, I will say, open all the panels. So it's one command, and it's, on Maestro serial 1, Maestro serial 2, do activate sequence 1 and 1, and then it'll activate all of that.
Because on the Padawan, you've really, I think you've only got serial 3 spare, haven't you, Steve? Or the hardware serial. I know you can have software serial.
Yeah, there's no reason why you can't use software serial. There's loads of pins free in the Padawan sketch. You only use a handful of them. And if you think about it, the other comms to like the Sabertooth, the Siren, and the I'll run over software serial anyway. It shouldn't make any odds. The only playing around I've done with so far has been over software serial.
Okay, cool. So yeah, so I think we'll touch on that a little bit later, but
we're getting ahead of ourselves.
Get to the Padawans. Okay, so hopefully that was kind of useful. What I would say, a bit like Anna's done, if you've not got one of these, just grab one. What I wanted to do in the first session is just make it, so it's not quite as scary. You can just power them up. You can get servos moving. You can get some sketches on there, and you can get playing. So if you get a chance to grab hold of one and have a look before our next session. What I was going to do is on the next one then is we'll step through the Padawan, and I think one of the things that's really useful to know is understanding a little bit more about the library that we use for the Xbox controller. Because what it does is then it lets you capture any of the key presses or any of the controls that are coming off the Xbox 360 controller. And then once we can capture and recognize buttons, it's just a matter of them mapping and deciding what buttons you want to control. So we'll step through the Padawan 360 on the next one, and then after that, what we'll start to do is grab the Arduino and see if we can fire off some of these scripts and get things animated. If that sounds okay.
Sounds great.
Yeah.
Thank you guys. I got mine all up and working, so awesome. Thanks.
Ooh, excellent. Hey, you've got servos moving.
Excellent.
Mm-hmm. I've got it.
Michael, very quick. I have servos moving, but I'm having an issue that when I run a sequence, either one of the servos stop moving, start running the sequence, and the other one start going around like crazy. And it happens to two servos all the time, the same two servos after a while. I don't know what it's doing wrong in here, but
okay.
It started good, and then one stops or two stops, and one start going crazy, going around and full speed.
Okay, and it's not can you see what's happening on the status?
It's showing the status is showing like it's doing the sequence, but look at this, and this one is not moving anymore.
Okay, so the display is showing it, but the servo's not moving.
No, the display showing the servos moving, like it's doing it, but it doesn't show this. It's going around like crazy. That's not part of the sequence. And the only way to stop this one is to take power off.
Is that maybe a timing issue? Is that maybe a timing issue, Michael? Like you were having?
Yeah.
Absolutely possible.
It could be, but they're 360
it's a rotating
servos.
servo. Could that be the problem in itself?
Could it be what? Sorry.
It seems like it's a rotating servo, not a 180-degree servo. Could it be that it's just confused about where it's located?
Is it 360 servo that?
It's a GS90, yeah.
Yeah, because it's rotating, it's spinning.
Yeah.
Yeah.
But it's all three blue ones are the same servos, and this is the only one doing that. This one.
Maybe something with that particular servo. I mean, if you could change
Must be a tough servo.
This one stops and this one's going crazy. So
Yeah,
I can change. I got more, so I can switch it to see.
Yeah, I'll swap the channels around on the
swap
on the
the two
board.
channels.
Do you have an oscilloscope to look at the actual signal coming out?
I'm sorry?
Do you have an oscilloscope to actually watch the signal? No.
Always start with the hardware.
Yeah, half the MG90s I've bought have been continuous rotation or just crap. So I definitely decided to stop buying knockoff MG90s and only
especially those transparent blue plastic ones are very, very cheap servos.
Yeah.
You may just be unlucky and have something with a technical problem with it.
Okay.
I've resorted to paying 3 times as much and ordering it from DigiKey or Adafruit.
Yeah.
Is this one of the cheap M90s?
Yeah.
Could be.
Is it an
I have-
FG now?
For the most part, they're really good. You know, they are pretty good, but just occasionally you can pick up one that's got a, you know, maybe a sticky pot in it or something that's giving the feedback as to its position.
Yeah.
And especially with 360 servos as well.
This is one that I have that looks like a Tower Pro, other than the label doesn't say Tower Pro, and this one actually works as a 90-degree servo, but I have another one that would just spin continuously, and it's completely unreliable. So, and they look identical. So that's why, kind of like you guys were saying, I just switched to just buying Tower Pros now.
Now it's doing it. I reset it. But this one is not moving anymore. This one here. Now this one is.
It's
crazy.
probably, it must, I'd imagine it's more likely to be dodgy servo than
And
it is
now,
to be.
there you go. And now it's not doing it.
Yeah, that's got to be a servo.
I've started buying these heavy duty ones. They are, oh, come on, there you go. They are very, very good. They're actual robotic servos, and they come with some nice bracketry as well. So these are pretty good. You can see it's actually, you know, it pivots instead of just like a servo arm. It's actually top and bottom. So yeah, they're great.
Is that Dynamixel or is that something else?
This is RDS 3115 robot digital servo, which I can't remember exactly where I got it from, probably eBay or something. But yeah, very, very powerful, very precise, and they're digital as well. So
wonder if something like that would work for BD1's legs.
So long as you can fit it physically, because it is reasonably chunky. Don't have a tape measure
So for
handy.
this SG90, what do you recommend? Which one?
What's that? The SG90?
Yeah, which brand do you recommend to replace?
Tower Pro, pretty good.
Tower
Does
Pro.
it one?
Yeah,
Doesn't the one that I have Tower Pro?
They have
I'd go for the MG90s rather than the SGs.
Yeah, they have a new MG90D, which is a digital, and it's slightly higher torque than the S.
Okay.
Yeah.
So I've started actually trying those, and they seem to be working really well, pretty reliable compared to these cheap Chinese knockoffs.
I've got some. I've just got these, which are Servos ones to test.
Servos are very, very good quality.
Yeah, these are the small, the same size as the SG and MG90s, but they're about the 3.9 to 5.4 kilo. So they're really chunky torque compared to the MGs. Because for whatever reason, I always end up with tiny spaces and lots of torque needed on most of the builds. So I'm really playing around with those.
In general terms, if you're looking for good quality servos and fast acting servos, have a look for helicopter servos. Because obviously with an RC helicopter, you want high quality and you want high speed. Servos are exceptionally good for helicopter servos as well. Just from my RC background, I would, you know, it's one of these things. If you want to just do some cheap and cheerful stuff and have a play around with it, buy some cheap and cheerful servos because you can get them for a couple of bucks. But you know, if you get to the point where you want to commit to this now and you want to use some, you know, some stuff to be ultra reliable, well, unfortunately, this isn't a cheap hobby. You are going to have to spend a few bucks to get to get that quality.
This is a request for your next thing. Could you put out a requirement for all the parts that you need for the Padawan 360 that'll be needed for Chopper? Because I think I've got some of them, but I don't have necessarily all of them. So, or is it the same part list that's on any of the Astromech sites or anything like
same,
that?
yeah. I mean, the Dan Krause's GitHub, which has got a list of all the parts, is probably the best place. The only bits that sit outside of that is things like amplifiers and speakers, which, to be honest, you know, we can share some of the ones that we would maybe use, but you can pretty much use anything you want as an amp, and you can pretty much use anything you want as speakers.
Are you doing one Maestro in the dome and one in the body for Chopper, or what? How are you doing that?
Yeah, so I've got a slip ring between the two, and I'll be running a Maestro in the dome because I've got 1, 2, 3, 4. I don't know. I've got a lot of servos in the dome.
How's the communication
1, 2, 3, 4, 5, 6, 7, 8. sorry, yeah, I'm just counting. There's at least 8 servos in there that I can see off the top of my head. So it'll.
How is the serial connection across the slip ring for the Maestro?
I've had no issues with serial or I2 squared across slip rings, but I know I've heard people say that that they can have issues with it. But personally, I've been running R2 for 5 years now on a link across a slip ring. What's your experience, Steve?
Again, it comes down to spending money and getting good quality stuff. The cheaper slip rings don't use sort of gold terminal contacts, whereas the more expensive ones, everything's gold plated, and should be very, very reliable. Say, it's down to it's a similar story. Pay money for reliable stuff.
Yeah, you can double up on the cables on the slip rings as well.
If you've got if you've got spares, that's what I've recommended in the past, is to just pair them together, twist them as a pair.
Yeah.
Last week, as a matter of fact, you said the exact. You recommended the exact same thing.
Oh, was that me?
Yeah, that was us.
Okay. Well, there you go. At least my message is consistent.
Hey, do you think the Maestro would be able to run some relays as well, or just servos and LEDs?
Well, it's a PWM device, so you should be able to run Arduino relays off it, because they're 5-volt relays, I would think.
Okay.
I haven't tried actually. Have you tried, Michael?
It's PWM output, so it's the same as RC. So any RC device will run off of that. So you would be able to run relays, yeah.
Okay.
You'll be able to run anything really, anything you can run off of PWM, and it's got a resistor for LEDs as well, so you don't have to put resistors in place.
Yeah.
Yeah.
Yeah, I might have a play if I get time.
All right,
Steve.
Because that would make the thinking gag for Robbie a lot simpler to try to coordinate. You know, the servo and then the relays and the servo again.
Well, I said if you just think of the Maestro as a automated RC box, like it's giving you the same outputs. So anything you can run off RC, which is PWM, you can send signals to it.
Okay.
Anyway, I need to unspotlight Steve now because I've seen Rick explode more than enough times.
Seen Sam's head popping out more than anyone needs to.
Exactly. Oh dear. Right, guys. Anyway, I think we'll call it a night there.
Thank you very much.
Yeah, thank you, Michael.
You. Been good fun, and
Good stuff, Michael.
We'll get some dates out for the next one. So I said next time we'll run in Padawan a little bit more deeply. Hopefully Steve will be around because he's the Padawan guru. We'll jump into the code and start to look at how we can pick up some things, and then we'll start to pull it over the next few sessions.
Thanks, Michael.
Thank you so much. Thanks,
Michael.
Thank you.
I'll see you
Take care,
next
everyone.
week on Drinks and Droids.
Thanks, Steve. Thank you, guys.
Drinks and Droids.
Drinks and Droids next week. Yeah. See you guys.
Excellent.
Bye.
Next time. Bye.